Okay, welcome back. I'm going to show you how to find the inverse of this matrix using that recipe that was on the at the end of that last video. So here's the recipe. Step 1 is to create a bar identity, making sure that that identity matrix is the same size. Step 2, row reduce until identity bar A inverse. Well, I saw identity bar B. We'll say that so it matches the last slide. Step 3, state A inverse is equal to B, or that A inverse does not exist. So that's going to be a statement that we'll have to make if it's impossible to row reduce this matrix A to the identity matrix. So let's see how this goes. Everyone loves row reduction. You love it even more if it's double row reduction. We're going to put twice as much work in your row reduction. We're going to put a second matrix in there. I want to create the identity matrix on the left-hand side. So what is the first move? Well, I have a leading 1 in the top left, but it's an unhappy leading 1. I need to zero out the 5 that's below it. So my first move is I'm going to replace row 2. Row 2 has a problem. That 5 needs to be turned into a 0. So I'm going to replace row 2 by row 2 minus 5 times row 1. And I have to do that operation to all of that first row on the left side and the right side. So what we will get is row 1 stays the same. Row 2, 5 minus 5 times 1 is 0. 11 minus 5 times 2, so 11 minus 10 is 1. And I have to do the same thing on the right-hand side. 0 minus 5 times 1 is minus 5. 1 minus 5 times 0 is 1. Okay, we're almost there. We almost have the identity matrix on the left-hand side. Now we have a leading 1 in the bottom right that's not happy. We need to zero it out. How do we do that? Well, we're going to replace row 1. Row 1 gets replaced by row 1 minus 2 times row 2. Let's see what we get. So 1 minus 2 times 0 is 1. 2 minus 2 times 1 is 0. Now we have 1 minus 2 times negative 5. So 1 plus 10. We have 11. And then 0 minus 2 times 1. So we're going to have negative 2. And then row 2 stays the same. So that was our step 1. I'm going to give these different colors. Step 1, step 2, step 3. I gotta wait for my cat to pass by. Okay. I still got cat butt in my way, but I'll keep going. This is step 1 up here. This was step 2 over here. Now we'll do step 3. We're going to state what A inverse is equal to. A inverse is equal to 11, negative 2, negative 5, 1. Okay, and that's our answer. I'm going to do a quick check. I'm going to confirm that this is actually the inverse. We're going to do A times A inverse equals identity. I'm just going to check one direction. That's safe. You don't have to check both. 1, 2, 5, 11 times 11, negative 2, negative 5, 1. So I got 1, 2, so 11 minus 10, I get 1. 1, 2, I get 0. 5, so 55 minus 55, 0. And then negative 10 plus 11, I get 1. So it worked. It's the inverse. We did it. We found it. We have confidence that all the row operations were done correctly. Next example, find the inverse of this guy. All right, Same thing, same recipe. I'm not going to write the recipe, I'm just going to do the recipe. So step one, 2, 4, 0, 2, 1, 0, 0, 1. I have a problem. I have a leading 1 problem. I want to divide by 2. But I'm going to be strategic. I'm going to play chess against this enemy. After I create a leading 1 in the top left, it's going to be happy. Then I have to create a leading 1 in the bottom right. I'll do that by dividing by 2, and that will create a fraction. I'm also going to create a fraction when I divide row 1 by 2. So I'm going to get fractions in a few different spots. Then I'm going to have to make this bottom right eventual leading 1 happy by zeroing out the number above it. So I'm going to play chess against this enemy. I'm going to replace row 1 by row 1 minus 2 times row 2. This is an advanced move. It's thinking 1 step ahead. I want to have that thing to be a 0 waiting for me. So 2 minus 2 times 0 is 2. 4 minus 2 times 2 is 0. 1 minus 2 times 0 is 1. And 0 minus 2 times 1 is minus 2. That part's good. And row 2 is the same. 0, 2, 0, 1. And now look what we have to do. We almost have the identity matrix. All we have to do is divide each of those rows by 2. So row 1 divide by 2. Row 2 divide by 2. And we have 1, 0, 1 half minus 1, 0, 1, 0, 1 half. Now the final step, thus we can state with some confidence that A inverse is equal to 1 half, negative 1, 0, positive 1 half. Did I mess something up? No. Okay. Let me do a quick check that A times A inverse is the identity. So 2, 4, 0, 2 times 1 half, negative 1 half, 0, 1 half. First row times first column, I get 2 minus 0, or sorry, 1 minus 0, I get 1. And then I get negative 2 plus 2, I get 0. And then 0 plus 0, 0. And then 0 plus 1, 1. There, it worked. So this is likely correct. Not likely, it is correct. That's the inverse. We could have started by dividing row 1 by 2, created the fraction. It's not like that would have been the end of the world, but now we have fractions, common denominators, and all that stuff. So save yourself the hassle if possible. Think at least one move ahead. Zeroing out a column in preparation for a leading 1 landing there. So it's like, you know, thinking about having guests over. You can clean up your house before the guests arrive, or you can clean up your house when they're there. It's better to clean before they arrive. So that's what we're doing. We're preparing for the arrival of the leading 1 by cleaning up that column for it before it gets here. Oh, 3 by 3, what are we going to do? The same thing. It makes no difference how big the matrix is, except for actually solving it, because it's horrible if it's big. So we have A bar identity, which is equal to 1, 2, 2, 1, 1, 2, 1, 3, 3. Bar 1, 0, 0, 0, 1, 0, 0, 0, 1. So the identity matrix has to have the same size. In the last example, we had a 2 by 2, so 2 by 2 identity. I should write the A bar identity thing. Okay. Here we go, row deuce. Let's see how it goes. I have a leading 1, and it is a sad leading 1. We have to make it happy. So my first move is I'm going to replace row 2 by row 2 minus 2 times row 1. I'm going to zero it out. Row 1 stays the same. 2 minus 2 times 1, 0. 1 minus 2 times 1, negative 1. 3 minus 2 times 1, 1. Then, right-hand side, 0 minus 2 times 1, negative 2. 1 minus 2 times 0, 0 minus 2 times 0. Now, row 3. Row 3 gets replaced by row 3 minus 2 row 1 as well. We have to do the same move there. So 0, and then 0, and then 1. 0 minus 2 times 1, negative 2. 0 minus 2 times 0, 1 minus 2 times 0. All right. Hopefully that's right. Hopefully I didn't make a mistake. Let me double check. Looks okay to me. I'm sure someone will correct me if there's an error. Next, do we have the appropriate happy leading one in the top left? Yes, but we have a lack of a leading one in the next entry. So we need to make that a leading one. Make into, well, that's not a very good make. I gotta make the make better. Make into leading one. Anyone ever take the, you have your phone, okay, not everyone puts their phone in their pocket, but if you put your phone in your pocket and then you take it out of your pocket, put it on the desk, and you still feel like the sound of text messages and emails, even though the phone's not in your pocket, it's like the phantom buzzing of messages. It just happened to me. I hate it. Okay, so what I'm going to do is I'm going to replace row 2, I'm going to multiply it by -1. Row 2 multiplied by -1. So 1, 1, 1, 0, 1, minus 1. And I have to do the same thing to the right-hand side. So +2, -1, 0, 0, 0, 1, -2, 0, 1. Okay. Now I have a leading 1 in the middle, but it isn't happy yet. It's almost happy. I got to 0 out the number above it. I'm going to subtract. So I'm going to replace row 1 by row 1 minus row 2, making sure we do the same thing on both sides. So 1 minus 0, 1 minus 1, 1 subtract -1, so 2. The right hand side, 1 minus 2 is -1, 0 subtract -1 is +1, 0 subtract 0 is 0. Row 2 stays the same, 0, 1, -1, 2, -1, 0, 0, 0, 1, -2, 0, 1. Oh, that was, this is not very nice, but we are almost done. We have 2 more moves to do. We can do them both in the same matrix. We have to make this bottom right leading 1 happy. It's currently very sad. The first move is I'm going to replace row 1 by row 1 subtract 2 times row 3 to 0 out that 2. And then I'm also going to replace row 2 by row 2 add row 3 plus row 3. So we get 1 minus 2 times 0, 0 minus 2 times 0, 2 minus 2 times 1. -1 subtract 2 times -2. So -2 plus 4, I'm going to get 3. Then 1 subtract 2 times 0 is 1. 0 subtract 2 times 1 is -2. It's so easy to mess this up. I may have made a mistake by now, but we'll double check at the end. Then row 2 is row 2 plus row 3. Oh, that's not so bad. Adding is much better than subtracting. 0 plus 0, 1 plus 0, -1 plus 1, 2 plus -2, 0, -1 plus 0, -1, 0 plus 1, 1, and then row 3 thankfully stays the same, and we're done. We just have one more real step to do, and that's to make a statement, a conclusion. Thus, it appears that A inverse is equal to 3, 1, -2, 0, -1, 1, -2, 0, 1. And I'm going to be really sad if I made a mistake. Let's do a quick check. A times A inverse is equal to identity. I'm not going to do the whole thing. I'll show you a shortcut to give you a little bit of confidence that you made it to the end correctly. 1, 1, 1, 2, 1, 3, 2, 2, 3. It's a little bit risky. So I'm just going to check a few spots. I'm going to check the first one. I'm going to do this times that. So I get 3 plus 0 minus 2. I get a 1. I'm going to check another spot. I'm going to check the one on the top right. I'm going to check first. Actually, I'm not going to check the first. I already checked the first. I'll check the second one. I'll be a little bit more strategic. I'm going to check the second row and the third column. So that's going to give me this entry over here. I get negative 4 plus 1 plus 3, which is 0, which has to be there in the identity matrix. So far, so good. And then I'm going to check the first row with the second column. So that'll give me this entry there. So 2 minus 2 plus 0, that's 0. I'm pretty satisfied. Good enough for fast check. It's got the correct entries to match up the identity matrix. Okay, another one. I'm a little bit nervous. Every time I see a 3 by 3, I get nervous. Am I going to make a mistake in this one? Is this the one? Okay, so I got to write a little bit smaller because I don't know how many steps this is going to take. 1, 1, 1, 3, 2, 3, 4, 3, 4, bar 1, 0, 0, 0, 1, 0, 0, 0, 1. Top left leading 1, deeply unsatisfied with its current situation. It needs to be reduced. It needs to be happy. To make it happy, we're going to replace row 2 with row 2 minus 3 row 1. So 1, 1, 1, 1, 0, 0, since we're not changing that row. We get 3 minus 3, 2 subtract 3, 3 minus 3, 0 minus 3, 1 minus 0, 0 minus 0. Now we have to do the same type of thing for the next row. Row 3 gets replaced by row 3 minus 4 row 1. So we have 4 minus 4, 3 minus 4, 4 minus 4. Uh-oh. 0 minus 4, 0 minus 0, 1 minus 0. Okay. I can already tell what's about to happen, but I'll keep going pretending that I have not seen the answer. I'm going to create a leading 1. I'm going to take row 2 and multiply it by negative 1. So 1, 1, 1, 1, 0, 0, 0, 1, 0, 3, negative 1, 0, 0, negative 1, 0, negative 4, 0, 1. Okay, and I have a leading 1 that isn't happy. So unhappy leading 1. So the next move, I got to make it happy. I'm going to replace row 1 by row 1 minus row 2. I'm also going to replace row 3 by row 3 plus row 2. So 1 minus 0, 1 minus 1, 1 minus 0. 1 subtract 3, 0 subtract negative 1, 0 subtract 0. And then we get 0, 1, 0, 3, negative 1, 0. And then we add those two rows together. Row 3 gets replaced by row 3 plus row 2, 0, 0, 0. And then negative 1, 1. And we have a big problem. It is now impossible to get the identity matrix on the left-hand side. That means there is no inverse. A inverse does not exist. This is wonderful. We're done. If we needed the inverse to solve a problem, it isn't so wonderful. But if it's just find the inverse of a matrix that doesn't have an inverse, as soon as we ever come across to any row on the left-hand side that's all zeros, we're finished. There's no inverse. Okay, next example. Let's continue in another video because we're at the 20-minute mark.